where I stopped yesterday. And shout out to Freya. I got the derivatives from I think this video here from her. I already tested, and it seems that it is not working in the correct way. I did some small changes in the way that I was calculating the normals and the binormal to create a circle, and I'm getting a better result now, but it's still not the thing that I want. So what I'm gonna do is just try some variations there. I'm gonna do this for 1 hour and a half. Let's put the timer. So the issue here is that I'm getting this twist, and I don't understand why. Uh, but I think it's pretty fucking cool. I was able to get this. And I think it is creating like a full tube. It's just that on that section it's getting the twist here. So I have to figure out obviously what is going on here. And I have no idea how I'm gonna do that, but the way that I'm doing now is by just getting the. So I changed the functions there. This one I kept like this. This other one I was doing with the exponents like t to the power of 2, but it looked like I was having a problem. So there was an error there because of this, and I think it's because of the. Like, I'm not 100% sure how the exponentiation works on C++ because you can also use the dereference operator, which is the same symbol when you're on the right parts of the assignment. So I think because of that, it like it gives you an error if you try to do the exponentiation like that. So I basically had to do the substitution here, which was the same way that was being done here. And then I just transferred the equation from the Freya's video to this one. So this is the first derivative of this equation here. And this is the second derivative. So the first one gives velocity, the second one gives acceleration. And in my mind, the vector that is the tangent is just the velocity normalized. Because just like the unit vector, let's say, of the velocity, just going to be pointing towards whatever the curve is at that moment. So I just call that function and get the velocity here, then call normalize. Normalize, and this is going to be the tangent, and the normal I'm doing as the acceleration now, and the binormal is just going to be the cross product of both, and then on the circle to generate. So for each point in the segments that I have there, just goes on a loop. I'm just calling this function and then passing these values. So the position of the points, the current point in the iteration, the normal, and the binormal. And this is the final vector where the points are going to be stored. And this equation here, this function I just got from 3GS. And the one that is being actually used to get the final points is the one with the indices, which I also got from 3GS. The indices is basically what creates the connection between the points to create the actual quads that are going to create the sections that are cylinders that are going to make up the path of the curve. So obviously there's something going on here. Not really sure what it is. One thing that I thought about doing is just by using only the normal here to calculate and see if that works. So I guess this is the easiest thing to do, so I'm gonna try this first. So the thing that is weird is that what they call, like the twist here is called torsion, I think, torsion, and is or jerk, and is the third derivative of the equation. And also something that Freya says is that the derivative of a polynomial of a Bezier curve is gonna be just the other Bezier curve. So the derivative of the cubic Bezier curve is the quadratic Bezier curve. So that's basically how it works, according to her. But it's also like the same thing. So like the quadratic Bezier curve has the velocity of the cubic Bezier curve. If that makes sense. And yeah, I'm not getting the torsion here, which is, it would be the derivative of the acceleration. So this is the reason why it's kind of weird for that should be giving the twist there. So I think the first thing that's worth trying is see, because here I'm generating the circle based on the function from 3GS, which uses a different approach, I think, to create the path. So it might be because of that. Yeah, but let me think about this. So like the way to imagine, maybe I can see on the videos, but the problem is that I need to find the right one that he shows the simulation. These videos are also very good. This channel is extremely good. I'm gonna watch the playlist here from all of the other stuff to review mathematics and stuff like that. Well, basically these three main vectors are called the Frenet frame. One is the tangent, the other one is the normal, and the other one's binormal, which is the cross product of both of them. And that creates a relative reference frame that follows the curve path. So for these three vectors, you can create the cylinders based on the angle, because the binormal and the normal are going to be on the plane that the cylinder is supposed to be at, and the tangent is going to be parallel to that point. So you get the tangent first, because the tangent is necessary to get the... Maybe don't even need to get the tangent, actually, if it's possible to get the normal from the acceleration. But the thing is, in the beginning I was going over... So this is the thing that is kind of confusing, because on one video he describes the normal as being one thing, and on another video he describes the normal as being something else. And so obviously it can be the case that it's just both of those things, but it's kind of confusing. So I took some notes here as well. I'm not sure if it's worth it to... There's a video here where he shows this movement. So the thing is, the torsion is the twist in this reference frame that happens when you're following the curve on a path. So it's probably this one, the torsion. Yeah, so I think it's basically on the beginning here. It shows. So this would be the reference frame. So the binormal, the tangent is the orange one, the normal is the yellow, and the purple is the binormal. So it's basically a reference frame that is based on the curve itself. And the equation of the curve, in my case, is the cubic Bezier curve, which is just a polynomial equation. So depending on the path of the curve, it generates this twist motion. And I think that this might be the reason why the curve that I'm getting there is the way that it is, because I'm using the velocity and the acceleration to create the plane that the circle is being drawn. So yeah, basically the normal is based on the acceleration, binormal is based on the other stuff. So the question is how to make it so that it's always the same width. I guess the first thing I'm gonna try is just to see what happens if I just put the normal there instead of the binormal. Because maybe if I do everything with the same vector, then it doesn't matter the direction of the vector, because it's still gonna go the full circle. And maybe this is the reason why it might be, but maybe it's not. So I'm just gonna test to see if it works. So if it doesn't work, I'm gonna see. So I took notes based on the videos there. So this is the curved, the Freya definition of the curvature is the determinant of the first derivative times the second derivative. So the first derivative is velocity, the second one is acceleration, divided by the magnitude of the first derivative, which I think is the length, but I'm not 100% sure. The way that they describe magnitude is by using this symbol here, I think. So this part I was trying to find videos on the mathematical notation because I forgot. But I'm pretty sure is magnitude. And magnitude, because these equations are expressed in terms of vectors. So I think that the magnitude of the vector is just the length. So just a scalar from the vector. Someone's saying that the future is unity. If you help Unity improve, you might get a discount on it in the future, helping Godot. I don't think like that. Yeah. Like my mind, I'm grateful that Godot's open source and I have access to all this code. And like I think about it in terms of becoming better at understanding the fundamental principles and eventually getting to the point where I can implement everything from scratch myself without relying on any library or anything else. So like if all these libraries and if I didn't have access to the internet anymore, everything was wiped out. I want to get to the point where I can build everything from the top of my mind. So I don't care about the framework. It's about becoming better at developing everything on my own and understanding everything from first principles. So I think it makes a lot more sense to use Godot for that. No, at least. Maybe I'll change in the future. So it's the magnitude of the first derivative to the power of 3. But on the videos there, the curvature is based... So this is the part that is kind of confusing, because one video he defines the normal in relation to the curvature, which would be... I wrote down here and here, but it's basically the same thing. Just the tangent magnitude divided by the magnitude of the velocity. So this would be the curvature. And the normal would be 1 divided by, or the tangent derivative divided by the curvature. But then on another video, he says that the normal is just the second derivative, as far as I understand now, like based on the notation there that he puts, which I might be misinterpreting. But is the second derivative of the first equation, which is the equation that defines the position. So he puts, I think, derivative of the tangent, but he describes the tangent as being the derivative of our relationship to S, which is... This part is the one that I might be confused by because of the notation. Because at some points you use S as the arc length, I think. So this one might be the derivative of the arc length and not the position. So this might be the reason why I'm getting confused there. But it's kind of hard in my case to understand or to think about like what is the derivative of the tangent, because I'm getting the tangent based on the normalization of the velocity. So I'm not really sure if the derivative of the tangent is the same as the derivative of the velocity, because he describes the tangent as being the derivative of the first equation, which is velocity, divided by the magnitude of the velocity, which I think is just the normalization of the velocity, because you want to get only the direction, not the magnitude of the vector. So this is the thing that I'm not sure. So I have to think about, I think I'm probably gonna try to implement the one that has a curve. So it's basically the acceleration divided by the k, which is the curvature. The curvature is the tangent magnitude divided by the velocity length, I think. I'm not sure if it's the velocity length or velocity. I took these notes based on the videos there, but I'm not really sure about the conversion. This is another thing, like this thing about Unity reminds me of, which I thought about because someone asked, today on a video, someone made a comment asking what language or if learning the way that I'm learning is good for them if they're just starting out. And I received some questions about this on previous streams as well. And I think that's something that is very important that people don't realize, especially people that are starting out. And I was like that as well because it's very hard in the beginning. You don't know everything and you don't know anything and everything is kind of blurry. So like, I think that there is a massive tendency for people to think about the tools because the jobs are obviously in terms of the tools. So people hire based on the tools. And this becomes very difficult. It makes it very difficult for someone that is starting out to understand that the tools don't matter. So like what matters is the goal. And the part that is like the reason why this is very hard to understand is because in order to understand this, you need to have clarity over the distinction between fundamental principles and the surface. So it's kind of like a paradoxical thing that's like it seems that the only way to truly understand is by learning in the first place. But then when you want to learn, it's hard because there isn't a way to anchor yourself on something that goes beyond the tools. So for example, when I tell people, usually when I say I tell people that they should think about what they're curious about and then build something. But then you get into this issue, which was a question that I always had since the beginning, and I still don't understand. Then I understand more now, but it's still very like not very clear to me. Which is like why certain languages are better to certain things, for certain things. And I think this is not clear to most people as well. They just do it because like it's something that everyone so for example, everyone says Python is better for automation, for artificial intelligence and stuff like that. But it's unclear if that's the case because of the community that built abstraction on top of Python that made a bunch of libraries that make it easier to do that, or if it's fundamentally something from first principles that makes the structure of the grammar that makes up the rule better for certain things or not. And I think that it is very hard in the beginning because of that. Like if you think about something you're curious about, then usually it's going to be very hard for you to find, to decide which tools to use to achieve that thing. And the reason why is because you don't have a clear understanding over the fundamentals. And it's kind of like a paradoxical thing. And yeah, but I think that's always better to try to learn everything or think about what you're curious about first. And then from that point, ask questions related to that thing. And then I think that this is going to be probably the path towards Like it's gonna be for now, it's gonna be trial and error because there isn't a better way. But you should always think beyond the tools and think about the fundamental principles because like everything is gonna be uh, everything comes down to a finite state machine. That's what basically all programming languages are. And the main difference between them is just going to be a variation of density in memory. So it doesn't matter that much which tool you pick for certain things because you're going to iterate and then you're going to adapt. So I think that the best of the both worlds is like first you pick something you're curious about, then you do some research on the market to see like what are the most popular tools and languages, and then you just see for that specific case where which category most likely would be the language or the tool, language and tools you would use for certain tasks. Then after that, it doesn't matter anymore. And then you should always be trying, as you're building stuff, to gain clarity over stuff that goes beyond the tools and the language, because those are just the superficial things that are going to change all the time. It's creating. Oh, so I think it's different this time than the other one. So now it's just creating the like the slice of the thing. Interesting. But it doesn't remove the twist. And I think usually for like the vast majority of people, it's going to be either JavaScript or Python that they're going to use. And the variations are more on the back end because of data, I think. So usually most people are gonna, if you want to build something on the browser, it's gonna be basically JavaScript, and then like the most famous frameworks. And if you're not doing something on the browser, then it's gonna be more backend, and it's gonna be C++ more for games, then variations of the variations of languages on the when it comes to websites on the backend servers is going to be based on how fast you need and how much, yeah, basically how fast you need and how much data. So usually it's going to be Python because the evolution of things. So everything is more likely to be integrated with artificial intelligence. So it makes more sense that Python is going to be more used more. But at the same time, you're gonna have C++, C, and Rust as well, because they have existed for a long time. It's unlikely that that everyone's will stop using them, and also they're faster than Python. So I think usually that's gonna be like it would be like most likely Python, C++, or Rust, I think. So those are, I think, the main three languages when it comes to the backend. And then for blockchain is obviously going to be Solidity, I think. And Rust is also useful for the blockchain. So after the selection of these languages, which are the main ones, then you're going to have the main frameworks for each language, but it doesn't matter which one you choose. Because what you're trying to do is always to figure out what is the fundamental principle behind the language. And I am thinking about, since like I got a bunch of questions about this, I'm thinking about doing streams again for the other channel. Because now I have a much clearer picture of how everything is connected. So it's like my mind's a lot clearer. I have a lot more clarity on how everything works. But I'm still not, I'm not 100% sure on like what is the best way to, and I'm not really sure if people would watch that. That's kind of the problem. Because usually, and there's another thing about the search engines, that's like people usually don't watch this kind of stuff. Hi mates, do you have any videos about Rust? Any recommendations? Fuck, I forgot the name of the guy. But for Rust, I just watched the main channels. Like if you type Rust on YouTube, I think I watched like, but there. I think the name of the thing is Zero to Mastery. Like the best. Oh, I didn't. To be honest, I didn't really. I think it's a waste of time. Zero to Mastery. All the other courses, in my opinion. But the best course from Zero to Mastery is from the guy that did the Rust course, and that course I think is very good. So from the Zero to Mastery, I think that's the Rust course very good. But it's also not like it depends on what situation you're on, because like it's gonna be, you have to think about on your circumstance, if you have a bunch of time or not, and how likely you are to put in the work. So like the more you can put work consistently and focused work, the more incentivized you are to just build stuff, because building stuff is the thing that is going to teach you the most by far. But if you have a lot of time, or if you notice that you have the tendency to procrastinate more if you force yourself to build because it's just harder, then you should combine that with watching a bunch of videos. So you should always try to balance stuff out. So I think for most people it's going to be 80-20 rule, I think. So 80% of the time watching videos and 20% building, because building is harder. But then you make sure that you allocate a limited amount of time that you can be really focused and build stuff. And that's going to be the most effective, obviously. But it's not that Rust is kind of annoying because there is a bunch of different there are things that are different than most languages, I think. It's basically traits in implementations. But the principles obviously are going to be very similar or the same. And I don't have a lot of experience in Rust either, but it's basically everything is always the same once you understand the fundamental principles. But Rust is more annoying because you have these types, and you have traits implementations, and it's kind of harder to understand how it works. Oh, and the start, I have experience with C. So it's gonna be super easy for you. Oh, I remember now. There's another. Fuck, I forgot his. Maybe let me see if I have like the best. But this is for more advanced stuff. There is a guy. I think he's Crust of Rust. The best guy that I found, but for more advanced stuff. And I still haven't watched all his videos because they're very long. But eventually, I was thinking about. I'm not really sure if I'm gonna have time, but yeah, this guy here, I think. So this guy is probably the best for more advanced stuff. Because the hardest part about Rust is the macros and the lifetimes, I think. So when it comes to all this, and obviously the types and implementations as well, because it's different than the other languages. But I think types and implementations is probably easier to get used to the more you use the language. And I think pointers are easier in Rust probably than C++. But it's honestly not that different, I think, from the standpoint of building stuff. So obviously is something else here. So what I'm gonna try to do is just change I'm gonna go back to the normal thing. And I'm gonna try to change the way that I'm getting the normal. So if it's not, this should be. Oh, no worries. So Let me see if I can implement the equation there. The thing is, this is the way that I was doing before, and it wasn't working, I think. But maybe I did it in the wrong way. So it's the tangent magnitude, which is the tangent length. I'm just gonna do it here. Tangent magnitude is probably gonna be a float. The thing that I said about the main question that I still have, and it's still kind of weird, is that it seems that, and it's not obvious to me at all why this happens, but there isn't enough, like, it's kind of hard to think about integrating languages. So this is the main thing that is kind of confusing, I think, from standpoint of even both people that are starting out and people that are more advanced. Because the question that I always had since the beginning is like, why can't I use both Python and JavaScript for the same thing? Like, because there's a lot of situations where you think about, and I think this is mainly when it comes to artificial intelligence, because usually people say you should use Python for artificial intelligence, and usually you're going to use Python on the back end. But the way that I was thinking about it is like, let's say you want to display something in the browser, and you're building the website with React, for example. Like, why can't I just use Python to deal with the artificial intelligence stuff on the, like, why is it so hard to integrate both languages? And there are some packages to do that. But the answer when it comes to that is because of the, obviously, it's going to be the compilation process. And I think that's where all the complexity is going to be. And usually the way you integrate both languages is going to be by meta programming, because a program is just a bunch of letters on a file. And a file is just a place in memory that has metadata that's going to allow the operational system to understand the sequences of bytes on the memory that make up the information that you are writing. And the keywords on the file are just going to be like based on the UTF-8 standard or whatever standard you're using. That is going to be like a predefined sequence of rules to translate the symbols into binary bits. So the question, and I think that I still couldn't find like a very good answer for this. So I think it's just because of the way like things evolved, and because people don't think about this too much. Because usually the way that it's going to happen is that people develop. It's going to come down to the source code of the integration of the operational system and the process you are running on the high level. So I think that's the reason why. And also is because of the nature of the electromagnetic field, but that's from the standpoint of physics, I think. Because what happens is that you have the variation of data. So the higher the variance, the more the language is going to be on the left, let's say, which is more chaotic. And the lower the variance, the more stable the language is going to be. And the predetermined set of rules that make up what the language is going to incentivize people to build abstraction in a certain way based on the funnel of information. So if you think about it, like the browser is just the eyes, let's say, and the server would be like the part on the back of the head that makes up the vision. So it creates like a projection, and yeah. So it's just a reflection of the electromagnetic field, I think. So when you try to, but I still don't see the point even knowing all of this, because it says but then it comes back to the fundamental thing that's like, why do it in, if you want to implement artificial intelligence, why do it in Python anyway? Because the most popular explanation is going to be because people build abstraction on that language, which is like just a self-fulfilling prophecy, if you think about it. So if you forget about that and think about from fundamental principles, I still think there is a difference because of the grammar. Otherwise, it would probably be like only one language, but that doesn't happen because the language is just a reflection of a network. So it's the symbolic representation of the network. And that's the reason why human beings have different languages as well, because it's correlated with space and time. So it's just the synchronicity of the network creates a symbolic representation, which is computation. So it's just conserving energy through Occam's razor by creating abstraction and people build on top of that. And that's what programming is. So I think the key to solving or to it's probably something that is going to change, I think, in the future. And I still don't see why it hasn't changed yet, which is mixing together different languages and also like increasing the osmosis, let's say, from one island to the other, which is basically what languages are. So each language is its own country. But if you have environments where you have high density of data and high variance, it makes a lot more sense to increase the fluidity between the two. So create mechanisms and tools to translate languages from one place to the other. So like I don't see, for example, a reason why you can't have a file that has both Python and JavaScript. And I think that the evolution of programming is going to be more and more in this direction. I think that's probably what's happening with React, that you have server components, because it's just the scope of the grammar that is the difference. I think this is probably not correct. Let me ask ChatGPT again, but the problem is not sure. So let me think about this. This is the equation here for the arc length. And I think that the derivative, this is the kind of problem, because I don't think this, I'm not really sure if it's the derivative of the first equation, which gives the velocity, or if it's the derivative in relationship to something else. Derivative in relationship to the arc length could be that. The arc length is just some, this is the distance between 2 points. And it's derivative because when you increase the amount of points, the limit converges to 0, because one point's right next to the other. So it becomes the derivative, and it's just the distance between the 2 points, and then it's the integral, which is the sum of the distances, which is just going to be the length of the curve. But I'm not really sure. So I'm gonna try to ask ChatGPT to see if like I get a useful answer. It's kind of hard because I'm not. I think the last time that I asked, I'm not 100% sure if the answer that I got was the correct thing, or just ChatGPT hallucinating. So let me think about this. So maybe the how can I get the curvature of a K is supposed to be the curvature, I think. So the normal is going to be acceleration divided by curvature. You got the curvature of the curve. I'm just going to ask the simple question. Calculate the curvature of 3D cubic Bezier curve. At any point t, you can follow these steps. Parameterize the Bezier curve. Blah, blah. First derivative, second derivative. Yeah, so it's saying that the curvature. So it's giving the definition of the, but it's not saying the determinant, which is interesting. So is the curvature scalar? So you just, but this is the thing because it's gonna be the same direction. That's kind of the problem. Yeah, but I guess I can do that. So I saying the derivative at the points. So in my case would be the velocity times the acceleration divided by the velocity to the power of 3. Is the magnitude. So how do I get the magnitude? So maybe I'll put vector 3 VA equals velocity times acceleration. Oh, fuck. Yeah, I think it's just going to be divided by, I forgot which one it is, but I think it's the velocity. So it's going to be the magnitude of this. But I don't think this is going to be enough there. That's the problem. So it would be this divided by, so for its curvature, it's going to be magnitude. Divided by, oh, it's velocity times velocity. That's length. This is the problem because I'm not really sure if it's gonna, because of the exponentiation. So I'm just gonna do it on another line. And then it's saying that the normal is this divided by curvature. But the problem is I don't think this is gonna work because it doesn't change anything. I think the issue there is a question of direction. Because the binormal and the normal are changing directions. So the question is how can I make the points only dependent on the plane? So yeah, I think that the easiest thing to do is probably to change the equation here. So the question is when I put the normal only, I think I have to change the equation. So I'm gonna test this first, which is probably not gonna work. And then I'm gonna go back to the other way, which is simpler, and I'm gonna try to think about, because I have both vectors which should be perpendicular to each other, so it shouldn't matter the direction of them if I change the equation of the circle there, as long as I have the, as long as I always build the points in the same order. So I guess this is a easier question to ask ChatGPT. So I can get the parametric equation to build the circle and just build it based on the normal. I think that's probably easier. So I don't think this one is gonna work, but it's still interesting. And I wanna go to in this direction that I'm going here because I think that's super interesting to like do these equations and then be able to actually see the visualization of whatever you build here. So like being able to translate the math into the simulation that is like really interesting. Mm. Damn. That's crazy. What the fuck is going on here? That's super interesting. So obviously it's incorrect, but it's still very interesting. It's kind of hard though because like I don't know how to make sense of this. Like why does it change so much when you're just I think the main difference here is just that I'm dividing by the curvature. So this is like something that is kind of concerning as well because like, even though the example that I have there, let's say I change the equation to build a circle and it's correct. It might be the case that at some points it's gonna like do something weird like this because of whatever reason. This is kind of the problem. So let me think about. I guess it changes a lot. But this is the thing because it could be the case that this sign. So maybe like I should get the absolute value, and that's the reason why it's changing a lot because going from minus to because I don't see how in my mind the only thing that the magnitude like let's say the curvature in one case is going to be 1 and the other case is going to be 10. As long as the direction of the vector is the same, I don't see how you would change the shape so much. Like in my mind, you would only change the how thick the tube is. So I'm not really sure what is going on. So I'm just gonna go back to the other. What I'm gonna do is just think about the equation to generate a circle. So let me build like this just see if I didn't change anything by accident. But I think I didn't. So let me I probably have here, but I'm gonna ask again. This is the equation that ChatGPT gave me the first time, I think. Which is just gonna be, so this would be vector 3, vertex, or actually just vertex. So is the first point, point position plus the radius times the cosine of s. Yeah, S I think is the segment, so this is cosine. But it's pretty much the same equation that ChatGPT gives. The only difference is that here is putting the radios outside, but it's basically the same thing. So I guess I'm gonna have to ask again or figure out how to get the yeah, the normal. Is it Has should be the normal. The thing that is not correct, I think, is unlikely to be the tangents. So the normal is the thing that I'm gonna have to change. Maybe I'm trying to see if I can think just like based on the visualization that I'm getting there, what might be incorrect by just getting the acceleration. Because the acceleration should be the rate of change of the tangents should be perpendicular, I think. So it's basically the same thing. I'm pretty sure that. So I'm gonna let me think about this. I guess the magnitude matters. So I can try to just do the acceleration without the magnitude. It matters because of the size, but I don't think it's gonna change the because the problem is the direction. So I'm gonna think about this. Why would be twisting? Like obviously the values are becoming smaller there because the thickness is decreasing. I'm trying to see if I can think in a way that you're just gonna change the equation of the circle there and fix. Like so, I can have something that is not dependent on the magnitude of the vectors and just on the direction of the plane. This is kind of the problem because like the values of the vector encodes. I think it's the ratio of the values of the vector that encode the angle. Just the proportion of them. If I get length, it doesn't make sense. So I'm gonna try to. Let's see. Because this is already. So let me just do acceleration, see what happens. I don't think it's gonna work. But I think that the normalized is already dividing by the length. This might be an issue as well. Oh no, it's just doing a copy from the vector. Then it's normalizing the copy. Yeah, so it's dividing by the length. Hmm. So the question is why when I just do the normal is it's kind of like a plane and it doesn't have the thing. If I'm multiplying by sine or cosine, it should be rotating. So I think that on that like thing, I'm pretty sure that there is a way to just change the calculation there, and because the ratio, I think the ratio between the values is the only thing that matters to encode the inclination of the circle, and then from that point, the magnitude should only be relevant to the radius. But maybe you do want to decrease or increase based on the curvature, like the size of the tube. But I think probably you shouldn't. I'm not really sure. And this is another issue of this stuff here. Like this is kind of the problem because the value there changes a lot, the visualization. So there's more variance. I can't zoom out more than this. So I'm trying to understand why it changes so much. So I'm gonna ask ChatGPT, yeah, ask Perplexity as well. So how to get the normal. Sometimes this happens. I have to refresh. So I think they check for bots. Show the normal of a 3D curve. Well, conflict tension. Our vector is the cross product of the tangent vector and the reference vector. Usually the up vector in 3D space. Yeah, I guess I can do that. The problem is that these would always assume a coordinates. It's kind of the issue. But I guess as long as I know that the coordinate that I have there is going to be, like the z is going to be up, I can use the z unit vector to correspond. And maybe this is the easiest way to do it. I was trying to figure out a way that like it doesn't rely on any specific vector, just based on the curve properties, which is, as far as I understand, the Frenet frame thing. Like you define the curve based on the reference frame from the curve itself. Like the equation of the curve gives you everything you need to determine the coordinates. And I think that this makes it more resilient, let's say. It's probably the same thing, but Let me try this and see like what happens here. Because it might be the easiest way, but it's something that is probably like more simple that I'm thinking about. Like maybe I'm overcomplicating my mind. But for other stuff as well, I didn't like this. Like for the control points, should define the control points based on unit vector of an axis that I choose. It seems kind of weird because like, usually we're thinking about defined based on the Z, but better in some situations the curvature would rotates on the 3 dimensions. Because obviously the position of the curves will change depending on the start point and the end point, which should influence the curvature. So trying to define the control points in a way that what they're in the 3 dimensions, let's say, I can put them specific axis. And I think that the reason why I'm trying to see whether or not this works. The same to get cross product of the tangent with the one of the vectors, one of the axes of the axis. But I guess it doesn't matter because the binomial is going to be the cross product from the normal. So you're gonna get either like you're gonna get both axes anyway. So I think in this case it probably doesn't matter. So maybe this is the easiest way. So hopefully it works. I think if it works, I'm gonna leave it like this. Because I just realized that in this case it doesn't matter. The control points is kind of different, so I might have to think about it. But in this case, it probably doesn't matter because you're getting the two perpendicular vectors that define the plane, and one is just the cross product of the other, so it doesn't matter. But I guess it doesn't matter because I'm picking like I'm forcing the z-axis from the tangent. I think this is probably not gonna work. Because the perpendicular axis from the tangent. How does this work actually? Because if you have a tangent, for example, that is on the z, if the tangent itself is on the z-axis, then the cross product is gonna give 0. I'm not. I think this is probably not gonna work, but maybe it does. Yeah. Oh, so it does work. Hmm. But it might be because the control points are on the z. So what I'm gonna do is just change the control points so that they are on the y. On Godot, as far as I understand, the z-axis is the green one, and I think I'm making the control points based on the. 'Cause it is interesting that this works though. Because in my mind, it's kind of confusing because the point is always changing, obviously based on the curve. So the tangent is always going to change based on the position of the point on the curve. So if the point's changing, the tangent is changing, but the axis is always rigid, so it's always the unit. So the cross product is supposed to give the perpendicular vector, but maybe it doesn't matter because like the normal in this case would be like the one that is pointing outside, so like would be on the y. So it doesn't matter the inclination of them. But what if it's this is kind of weird. I'm not 100% sure if I understand why it works because of the situation that I was talking about there. So when you have two parallel vectors, the cross product of them is going to be 0. So in the case that the normal is, I'm not sure if it's because of this case here, the way that I'm doing on this specific situation with this start and end point, it doesn't get into the situation where the normal, where the tangent is parallel to the z-axis. In a situation like that, the normal would be 0, and then in my mind, it would mess up the equation here, because even though you have the other sign, like the other position of the point being defined by the binomial, this one would be 0, so it wouldn't do the rotation correctly, in my mind. So the question is, how can I test this? So one thing that so what I'm gonna test now, it's probably not gonna, it doesn't clarify this, but I'm just gonna see if I change the axis of the control points, what happens. So if I put y, yeah, y here, So I'm defining the control points that make up the Bezier curve based on the midpoint. So the point in the middle between the ends and the beginning of the curve, and then I rotate I put both points in the middle, and I rotate the control 1 by 45 and the control 2 by negative 45. Because in my mind, they're gonna be like on the opposite sides. And the control points are the weights that make up the shape of the curve. Because a Bezier curve is just a collection of linear interpolations. So if you make up a polygon in 3D, and then based on the path of the polygon, for each part of the curve, you have a polynomial equation that defines the path of the point. So the final polynomial is just a multiplication of the segments of each linear interpolation. So I guess what I can test you should do is to start the curve at the 0, but I'm already starting at the 0, I think. I can start in the same axis. I think I'm starting at 0, so I can start in the 0, 0, 1 and see what happens. I can start on the z-axis. As it doesn't change anything. So next thing I'm gonna do is put the starts on the z-axis. At 0, 0, 1, 0, 0, 1. So I think if this works, then I'm just gonna move on. So I'm gonna spend a bunch of time studying. So based on all the lectures and all the stuff that I watched to figure this out, I wrote down a bunch of things here. So yeah, one thing is to review all this math related to the triangle math and all this stuff related to manipulating these points on 3D. I think it's gonna be very useful to review all this stuff. And then on top of that, I have all these keywords here that I wrote down. And all of them are based on procedural mesh generation. Just the fundamental principles, I think, which I think is extremely interesting as well. So being able to visualize stuff on 3 dimensions. I think the fundamental principle is going to be topology, which is the branch of math that studies the shape of fields, I think. So there's both topology. Another thing that's extremely interesting is the equations of the electromagnetic field, which so mainly electromagnetic field and complex plane are the ones that I'm the most interested on. But also, I'm gonna put here to study, because this is always something that has been very confusing to me. How does the computer compute sine, cosine, and complex numbers? Because I know that a complex number is just going to be a data structure, so it's a class. But when it comes to the actual physics, it's interesting for me to think about how does this work? Like, is the representation of the computer an accurate representation of what a complex number is in reality, or is it just a reduction that like happens to work to a certain extent, but it's not the same thing? That makes sense. And it's really hard for me to think about this. Because on the class there is going to be basically defined by floats. So I wanna clarify the distinction between what is actually happening when it comes to the computation and the math. So if they are the same or not. And the other thing that is very interesting that this guy has here a bunch of videos as well is on the vector. So this is something that I might explore soon after after I do the stuff that I'm trying to do, which is just the graph visualization. I'm gonna think about this. Like, I'm probably gonna start working at this after I watch all these videos already. I found all these other libraries here as well for mesh generation, physics, and stuff like that. So I probably create a framework on the Blender folder here that is gonna allow me to build vector fields, for example, and visualization of the vector fields to do a bunch of studies. And in order to do that, you need to, I think I'm gonna need to build a class for the edges, the faces, and the vertices. I think those are the three components to create the meshes. And then just build a bunch of functions and probably classes to build like vectors and translate all the math that I learned from all these concepts into the visualization. That's gonna be very interesting. There is a lot of stuff. I haven't studied this one yet. I'm probably gonna do this some like very soon, some other stream probably. So I don't know which one I'm gonna start with, but I think that these libraries here, they are for differential equations, so partial derivatives and stuff like that. I'm probably gonna watch these videos after I stream today, which is just like trying to understand how people usually do the integrals on C++. But I didn't find too many videos of people doing this. I think derivatives is a lot easier because you just get the definition of the derivative. But integrals, I think it's probably gonna be easier. It's gonna be easy too, but it's hard to think about the best way to do it. And for the sine and cosine algorithms, I already saw videos some time ago. And it is kind of like the optimal, the final way, let's say, that people do it today. Not very obvious, and it's kind of confusing to understand how they do it. How they encode the sine and cosine equations. I'm probably gonna review all of this first, and then once I finish these ones, I'm gonna go over all these topics here. But I'm thinking I'm gonna go in this the order that I have here. Probably gonna go based on whatever I'm trying to do at the moment. It looks like it's still correct. Yeah, so I'm pretty happy about this. It was very hard to do it. The thing I'm not sure is that when you look, but I think this is just a Godot thing, because the normal cylinder that they have on the primitive is also like this. It seems like it's cut off here. I think it's just because of the culling that happens. But I think it is the thing that I was trying to do. So it's like it should work as an edge. Yeah, so the only thing that I'm gonna do now to change this is gonna be to actually now that I think about it, so there's two different things that I have to do still. One is to add the arrow to the curve. And I think the way to do this is just by getting like the final section and then changing the ratio. Basically changing the numbers. So I can change on the loop here. So when it gets to the final iteration, I do some other equation, some other function that generates a cylinder instead of a circle. And then I just find, based on the equation there, I just look for perplexity or ChatGPT to get the equation that is going to allow me to draw the cylinder based on the parameters that I put on the class. It's just going to change the width and the width and width of the base and the top. And I think that the other thing I have to do, which I don't think is happening right now, is to fill the start point. But I'm not really sure if that matters that much because like the purpose of this is going to be to connect one node to the other. So I don't think it's going to be visible anyway. But it's probably better to do it. Because the way that this is happening here is like it's connecting the points through the two cylinders, that the segments that make up the curve. And I need to, on the first iteration, I need to figure out how to connect the points also on the face. So that is like, it puts triangles here. But I think that's just a matter of figuring out the indices. So what I can probably do is just create another function after the loop runs. Before I call this one, I call I create another function here that just goes over the first, just goes over the segments and then puts the indices of the segments first based on the center point, which is the start point. But I think I'm gonna stop here. I'm gonna think about this some other time. And now I'm just gonna, after the stream, I'm just gonna watch the videos here. So probably I'll think about this tomorrow on how to finish this. So the main things that I want to do is just the arrow at the end, and then to close the beginning of the arrow. Then once I do that, the only thing that I'm going to do is just change the member variables here, the variables that I'm using. I'm going to put everything as a member variable and subscribe everything, all the member variables involved in the thing. I'm going to subscribe on the methods there, on the properties, to expose them on the editor so that I can change the values on the editor of the curve segments and everything else. Then once I have that, and once I have that, I'm going to think about which direction I'm going to go. Either I'm going to continue to build the stuff here inside of the Blender folder. I'm thinking about creating, like I said, more classes that are gonna allow me to create geometry based on triangles, so that the faces, edges, and the vertices, and like spend a bunch of time studying these other libraries. Or I'm going to continue to build the thing that I was building before all of this, which is just the graph there. And I'm definitely gonna continue to build that, but I'm not really sure which one I'm gonna do first. Yeah, so I'll have to think about this. I think I'll probably study this stuff, all these things here, and then continue to build the graph until I get to the point where I have on the softwares on the front end. I Once I get the same stuff on the front end there, then I can go back and focus on this other stuff. I have to review this stuff here as well. This is weird because of the properties, but I'm not really sure if it's just a warning because I'm setting this stuff on C++. I'm gonna have to think about this as well. Oh yeah, the next thing, the problem I'm gonna do actually is to figure out the camera. So I'm gonna create another camera class that is gonna have by default the zooming, panning, and stuff that I had on the other projects. So I don't have to think about all this stuff. So I'm just gonna create another class that inherits from Create 3D, and I'm just gonna put by default the movements that I had before, which is just panning, zooming, and yeah, just basically panning and zooming, so that I can visualize stuff on the game. That's probably the next thing I'm gonna do. Then after I do this, I'm gonna think about which direction I should go. Either continue. This obviously I'm gonna do both, like I said, but which one should do first? I'm gonna think about after. But now that I remember, I'm definitely gonna do the camera first, because it's just something that I wanna get over with. So finish the arrow, then create another camera class, put the events. Then after that, I'll think about these two paths, which one to go with. So I'm gonna stop here, and not sure when I'm gonna stream next, but yeah, see you next time.